Large language models are often visualized as vast, all-knowing systems, but in practice, they operate as opaque processors of chaotic data streams. While the industry treats these models as reasoning engines, they are mathematically restricted to probabilistic text generation, predicting the next word based on statistical weight. This statistical nature creates a hard ceiling for enterprise use. In high-stakes environments, a decision requires verifiable logic, not a likely sequence of characters. The failure is quantifiable. When LLMs are tested against Z3 SMT solvers, the benchmark for formal logical satisfiability, their accuracy in designing autonomous logical processes drops to 13%. This is the black box problem. There is no mechanism to audit the training data, the internal weights, or the specific criteria the model used to arrive at a high-stakes conclusion. Modern enterprises demand the opposite. Strategy and compliance require absolute transparency, where every step of a decision can be traced back to a verified rule. A system built on statistical probability cannot serve as a reliable foundation for corporate strategy, effectively capping the economic utility of current generative AI. Because of this unreliability, highly skilled knowledge workers are increasingly bogged down by the need to manually verify every AI-generated output. The result is a state of hindrance. Instead of accelerating workflows, the frequent hallucinations of current models force organizations into a cycle of constant fact-checking and revision. ExoLobe is designed to break this cycle by shifting AI from a purely generative machine into a strictly guided system. We treat the large language model as a dynamical particle, one that must navigate a deterministic latent space governed by predefined logical bounds. This is reasoning as a service, a platform designed to maintain an optimal problem-solving trajectory by enforcing precision at every step of the inference process. The platform does this by extracting the underlying methodology from a problem, learning the rules of the process rather than simply predicting a plausible answer. Enterprise value is rooted in the causality of the process. ExoLobe provides a verifiable logical path that replaces the statistical guesswork of standard generative systems. To solve the black box problem, ExoLobe utilizes a structural framework that forces AI into mathematical compliance with human logic. Our core technical moat is the STMC formalism, which translates human expertise into a structured language of mathematical objects. The first component, Schema Tokens, uses modal logic to define exact states of possibility and necessity for any given proposition within the system. The second component, Methodology Components, acts as the procedural engine. As shown in the code here, these units possess strict preconditions and postconditions that must be met before any change is executed. An MC will only transform the state of an ST if every built-in constraint is satisfied, ensuring that the logic remains sound throughout the entire workflow. This hard-coded framework is far more resilient than standard prompt engineering, which is susceptible to the inherent instability of the underlying model. These logical guardrails proactively prevent hallucinations and logical leaps by forcing the system to engage in continuous self-critique and backtracking. By converting probabilistic text into these verifiable procedural units, ExoLobe creates a technical architecture that is difficult for simple API-based wrappers to replicate. These logical units are organized and deployed at scale through a centralized knowledge management system. This is the OTKB, the Optimization Technique Knowledge Base. It serves as the central brain that manages and routes methodologies across the ExoLobe platform. The process begins with the generalization pre-processing algorithm, located here in the top right of the architecture. This algorithm ingests raw data and academic research, standardizing complex information into the strict STMC logical format. These standardized units are then stored in the EMCL repository, which builds the platform's procedural intelligence over time. EMCL houses hundreds of thousands of verified problem-solving methodologies. It functions as a comprehensive procedural library, mapping out how complex systems operate. As more methodologies are ingested, the system's intellectual volume compounds, creating a data flywheel that increases both the speed and accuracy of the platform. To navigate this library, ExoLobe uses the Dynamic Orchestration Scaffold, or DOS engine. The DOS engine selects and stacks the optimal combination of methodologies from MCAL to construct a custom solution tailored to a user's specific problem. This structured approach to reasoning also provides a significant advantage in operational costs. By utilizing KV cache quantization and mixture of experts routing, ExoLobe reduces the inference cost per token by 60% compared to traditional methods. The platform delivers a higher degree of logical accuracy while remaining more cost-effective to scale than brute force foundational models. ExoLobe's market strategy is model agnostic. We treat heavy infrastructure like foundational LLMs and cloud computing as interchangeable commodities. This approach allows us to avoid technical lock-in while maintaining full control over the high-value cognitive workflow layer where the actual reasoning happens. Phase 1 focuses on the launch of our MVP, ExoLobe Insight, to establish a foothold and validate product-market fit. We are targeting professionals who require verifiable logic and are currently underserved by the inconsistent outputs of general-purpose AI. Our pricing strategy is designed for rapid adoption, entering the market at $18.90 per month, significantly lower than the current industry benchmark for premium AI services. By providing guaranteed logical guardrails at a competitive price, we can achieve rapid customer lock-in within high-value sectors. This initial phase is designed to ignite our recurring revenue by solving the specific problem of AI unreliability for a motivated user base. In Phase 2, the platform evolves into ExoLobe Advisory, scaling its impact over the following 24 months. Here, we embed ExoLobe directly into enterprise networks, where it functions as a proactive agent for B2B and B2G clients, autonomously suggesting optimizations based on internal data. The final phase, ExoLobe Agora, represents our transition into a broad industry ecosystem. Agora positions ExoLobe as a foundational reasoning layer for the knowledge industry, providing a standardized environment for complex decision-making. By opening our SDKs to external developers, we allow a global network of researchers and experts to contribute new methodologies to the platform. While our competitors focus on the statistical possibility of a correct answer, ExoLobe focuses on the mathematical causality of the entire process. By automating the structural labor of logical design, we allow the user to focus their attention on the qualitative judgment of a solution's semantic value. ExoLobe shifts the focus of the knowledge worker toward high-value strategic assessment. We are providing the foundational reasoning layer for the data-driven enterprise.